In 1965, one programmer added a feature so convenient it's now caused billions in damage, and he spent the rest of his life apologizing for it. His name is Tony Hoare. He's a legend. He invented the quicksort algorithm, won the Turing Award, got knighted. But there's one decision he calls his billion-dollar mistake. And here's the twist: it wasn't a bug. It wasn't a typo. It was a feature he designed on purpose, because at the time, it seemed obviously good. That feature is the null reference. The idea that a variable can point to nothing at all. And almost every language you've ever used inherited it. Let me explain what that actually means, why it's so dangerous, and how it's still crashing software you use today. Back in the 1960s, Hoare was designing a language called algol-w. He wanted a safe type system, one where the compiler could guarantee your program wouldn't blow up. But he hit a problem. What should a reference point to before you've given it a real value? What's the default? His answer was simple. Just let it point to null, a special value meaning nothing here. It was easy to implement. It felt natural. So he did it. In his own words, he couldn't resist the temptation, simply because it was so easy to implement. And that single choice rippled out across the entire history of programming. Here's why null is a poison pill. When your code expects an object but finds null instead, and then tries to use it, everything falls apart. You ask for a customer's name. But the customer object is null. So the program reaches into nothing, and the whole thing crashes. In Java, that's the infamous NullPointerException. In C and C++, it's a segmentation fault. In JavaScript, it's cannot read property of undefined. Different names, same original sin. And here's what makes it so insidious. The type system lies to you. It says this is a string. But secretly, it could also be null. Nothing warns you. So the bug hides. Your code compiles fine. It passes most tests. Then one rare path, an empty database, a failed network call, hands you a null, and production explodes. This isn't theoretical. Null-related bugs have caused real outages, data loss, and downtime at some of the biggest companies on Earth. Hoare estimates the total cost in the billions. And it gets worse, nulls aren't just crashes. They're a security problem too. Null pointer dereferences have been the root of countless vulnerabilities. Attackers trigger a null where the program didn't expect one, causing denial of service crashes or worse, a foothold to exploit. For decades, developers just accepted this. You scattered null checks everywhere. If this isn't null, do the thing. Defensive code, cluttering every function, guarding against a ghost. But think about it, that's insane. We were manually patching a flaw baked into the language itself. The fix was always treating symptoms, never the disease. So a new generation of languages asked a radical question. What if null simply couldn't exist unless you explicitly allowed it? Take Rust. In Rust, there is no null. Instead, if a value might be absent, you wrap it in something called an option. It's either some value or none. And here's the beautiful part. The compiler forces you to handle the none case before you can touch the value. You literally cannot forget. The crash becomes impossible. Kotlin took the same idea to fix Java's mess. A regular string can never be null. If you want a nullable one, you add a question mark. The type tells the truth. Swift does it too, with optionals. Before you use a value that might be missing, the compiler makes you unwrap it safely. The danger is visible, not hidden. This is the deep lesson. These languages moved the problem from runtime to compile time. Instead of your users finding the bug at 3 a.m., your compiler finds it before you even ship. That's the difference between a mistake that costs $1 billion and one that costs you 30 seconds fixing a red squiggle in your editor. And here's the part one love. Hoare didn't hide from this. In 2009, on stage at a conference, he stood up and publicly apologized. He called it his billion-dollar mistake. Think about the humility in that. One of the most decorated computer scientists alive, admitting that his convenient little shortcut caused half a century of pain. But there's a bigger takeaway for every developer watching. The most dangerous decisions aren't the hard ones. They're the easy, convenient ones that feel obviously right in the moment. A shortcut that saves you 5 minutes today can quietly cost the industry billions over 50 years. Design decisions compound, for better and for worse. So next time you reach for the quick fix, ask yourself Hoare's question. Is this actually safe, or does it just feel easy right now?